All right, guys, we're as we work through your book, we're in Chapter 2, Section 6. We're actually going to cover 6, 7, 8, probably, and 9 today. Just really quickly, this is stuff you should have seen in junior high school. We'll make this quick and easy. So we're writing, write and use ratios, rates, and unit rates. Write and solve proportions is the idea. And here's some of our vocab words: ratio, rate, scale, unit factor, conversion factor. Again, these are now junior high topics. You should have seen them 7th and 8th grade, or 7th or 8th grade. We're talking about ratios. Ratio is a comparison of two quantities by division. So when we write the ratio, we can use that little colon sometimes, or semicolon. I always figure out which it is. I think that's a colon. Oftentimes we write a fraction as long as that denominator isn't 0. Rates that have the same that name the same comparison are said to be equivalent. So equivalent ratios, when we put two equivalent ratios together, we call that a proportion. So we've seen these proportions before. Sometimes we write them in a table, sometimes we write them in an equation, but pretty simple. We can see the relationship between them. For example, the relationship here is we're multiplying by 2 to go from left to right. We're multiplying by 12 to go from numerator to denominator. We're multiplying or dividing by 2 to go from right to left, and so on. And here's a way to read that proportion. We say 1 is to 15, 1 is to 15 as x is to 675. So our idea today is let's figure out what the value of that x is. And again, there's lots of ways to get there. The thing we want to talk about today is what's called cross-multiplying. And we don't like to use that phrase very often in junior high simply because students get it wrong often. They say cross-multiplying when they mean multiplying across when they're solving, when they're multiplying fractions. Cross-multiplying means multiplying across the equal sign. We call this cross product sometimes. In the olden days, they used to say the product of the means is equal to the products of the extremes. When I was in school, that's a big phrase. What it means is if we want to solve for x, we multiply the two numbers that are opposite each other on the equal sign, so the one numerator, one denominator, that would be 675. That's equal to the product of the other two values, equals 15x. And now we just have a divide by 15, and we get our answer, whatever that happens to be. And it happens to be 45, so x equals 45. I do want you to know the reason that works. I usually spend a lot of time on this, figuring out why that works. It's because of that multiplication property of equality. So one of the reasons I have you learn to clear out fractions is because it's the same idea here. The common denominator between those two denominators, it happens to be 675. And when I multiply both sides by 675, what happens is on the left, 675 divided by 675 happens to be x. And on the right, 15 goes into 675 45 times. So it's because of that multiplication property of equality, about that clearing out fractions. That's why one of the reasons I wanted you to learn that is because there is a reason it works, and it helps us to solve these cross-multiplying, these proportion problems. We use these a ton. These ratios and rates, proportions come up all the time. Anytime we have an equivalent ratio, it comes up. Percents, almost anything we're doing, these proportions come up. So let's see, this says the ratio of number of bones in the human ear to the number of bones in the skull is 3 to 11. So I'm going to set up a proportion, 3 to 11, and it says there are 22 bones in the skull. How many bones are in the ears? So what I want to do here is I want to make sure that I have the right number of the right numbers in the right place. So this says the number of bones in the human ear to the bones in the skull. Bones in the ears is up at the top, and bones in the skull is down at the bottom. Then it says if there are 22 bones in the skull, so the 22 bones in the skull, I need to make sure I put that number in the same place. And I'm looking for my value here. Again, we want to make sure that we put the right piece in the right piece. We don't have to label them, but I find it helps sometimes just to write down and make sure we know what's going where. Now I can solve this a couple different ways. If you notice that this is times 2, That's great. You can multiply by 2 here. And we would know that there were 6 bones in the human skull. If we didn't recognize that right away, we could cross multiply. We could use that method of the product of the extremes. 3 times 22 is 66 is equal to the product of the means. Means meaning middle. That would be equals 11x, and then divide by that 11. Divide by the 11 would give us that there were 6 bones in the human skull. So that seems really obvious. They're not always that obvious. I want to show you a couple examples where the numbers don't come out quite that nicely. So here's an example. I don't know how many times 7 goes into 15 exactly. So I can't eyeball this one and tell what the answer is, but what I can do is I can cross multiply. 3 times 15, that's 45, equals 7 times x, that's 7x. Divide by 7. My answer for x would be 45 over 7, which again I can leave like that or write as 6 3/7. Here's another reason why we want that cross multiplication, that method of solving these. Sometimes our denominator could have more than one term in it, in which case, again, we can't just eyeball it and tell what x should be. So we would cross multiply. 10 times x, that's 10x. And then when I'm cross multiplying, it's 9, that numerator times the entire denominator. So that would be equal 9 times the quantity x plus 2. And then we would distribute 10x equals 9x plus 18. And we can solve minus 9x minus 9x. X would equal 18. Okay, so there are reasons to have that method. Sometimes we can eyeball proportions, sometimes we can't. And at this point, you guys use whatever you need to get to that point. So here's another quick example. The ratio of games lost to games won for a baseball team is 2-3. And the question is how many the team won 18 games, how many games did they lose? So let's see, lost to won. Lost would be in the numerator, won would be in the denominator. The team has won 18 games, so I need to put that number of wins where the number of wins go, and that's in the denominator. And then I can cross multiply. Or I can notice I'm multiplying by 6. So multiplying by 6 here would give me x equals 12. They lost 12 games. Now be careful, these questions could be worded differently. It might ask how many games did they play in total. Well, if they won 18 and they lost 12 in total, they would have won 13. Just be careful on the wording with these questions. Make sure you're answering the right question. We've got some things here about unit rates. Unit rates means per one. These are pretty easy to figure out. We just want to figure out what it is per one of something. So for example, if you say your car went 35 miles on 2 gallons of gas, the unit rate would mean how many miles per 1 gallon of gas, and you just divide those out to get 17 miles per gallon. Per gallon, we mean per 1 gallon. Ralph Lau of Germany flipped a pancake 416 times in 120 seconds. The question is, find the unit rate. So unit rate would be, that's pancakes per second. And to get that, I would just divide it out. I would divide the numerator by the denominator. My answer should be here. About 3.47 pancakes per second would be the unit rate there, okay? Same idea here. Corey earns $52.50 in 7 hours. Find the unit rate. The unit rate there would be how much he's earning per hour. And again, we just divide that out. It turns out he earns, or she maybe, earns $7.50 per hour. Just some quick questions here. I know the answers show up, but I would pause, see if you can find those all out. This last one, a car travels 180 miles in 4 hours. What's the car's speed in feet per minute? I would probably, to do that, change the miles, the 180 miles, to however many feet that is by multiplying by 5,280. And then the 4 hours, I would change that to minutes because they're asking about minutes by multiplying by 60. So whatever big number over 240 minutes would end up giving me that. But pause here, see if you can get those correct answers. And then check out these last 3 quick questions, all right? I put numbers of questions I want you to answer, either in the book or at the link I'm sending you. These have real world applications, so we do want to be able to solve proportions, but algebraically, I'm more concerned that you can answer something like this right now. The other things we've been doing for a couple of years now. All right, have a wonderful Wednesday. Anything you want to talk about these on Thursday, Friday, we can. All right, thanks guys, bye.